Hello everyone from the world's smallest lab. This has been K4ZEP. Been working on this strange little self-running motor by the Italian gentleman, and also a replication that the gentleman now says is a fake. And I've been playing with it just to see what I could see. This is a basic motor, and I added some extra magnets to the top of the magnets out of the microwave to increase the field a little bit, and also I can key off of those smaller magnets easier with this reed relay right the camera's not focusing, right there. The schematic is right here. Unfortunately, I ordered some normally closed relays, and my old eyes saw ND and I thought it was NC, and so I got a nice package of normally open relays today. And so I use this reed relay here as a normally open to control this relay down here, which does the actual switching across the two coils here. The coils are 110 volt solenoid coils packed with soft iron a la Bedini glued in there. These are out of just plain old microwave magnets. This thing under here might look like a motor, but it is actually the bearing, just the bearing from a VCR, which has given me probably 100 hours of different types of motors that I have built. First thing I'm going to show you is the waveform when I spin it. Now I have bumped this sucker. There we go. I bumped it making the video here. That's the waveform I'm looking for. As you can see, my coils are not saturated and staying saturated the whole time. The LEDs that are across this circuit that conduct and causes the current to flow when the contact opens at the required time. Now when it's very low or just oscillating back and forth here, you can see both sides of the waveform here. That's a standard waveform you would see out of a generator. I'm swinging it back and forth here. And here's the funny thing. When we run it here, it is so close to running. Watch it here. It'll sit here and oscillate back and forth for a long time. And then let's see if I can adjust my so that's it. And I gave it just a slow little just not quite there. I am so close. I'm actually using two LEDs and a diode in series as the circuit that completes the loop while the contact is open, and then the relay, when the contact closed, shorts the loop for the rest of the way around in the negative producing direction. And so that's it. It's close, and it's very crude, and I can obviously see that my coils aren't right, but the waveforms are correct from what I would expect. And the polarity in that direction is what does drive the magnets away from both cores in this mode. So I'll keep working on this, and the little thing sits here and rocks and carries on. So it's close, and I just like to watch the pendulum effect here. I discovered that by accident. And the click you hear is the actual relay here, which is doing the normally closed function driven by the normally open reed relay, because I screwed up and ordered the wrong relay. So that's it for now, folks. There's going to be a major rebuild on this when I get some U-metal in, and I have to have a way where I could shim this device. I believe my magnets are actually too close to my cores and that's part of my problem right now. It's drawing it back. If you watch it carefully, you can see it actually push away, but then the core is stronger than the push, so I don't know if I can find a neutral point there where the push will be stronger than the core or not. That's really the crux of the question. So that's it. From the world's smallest lab, this is Ben, and I'm gone.